Good morning and welcome back. Section 11.3, Day 1, Hyperbolas. So you can see a nice long definition of a hyperbola. Definitely a good read. Look at all the information. I'm going to jump right to the heart of this, which are the equations. And if you take a look at your equations, there's basically two styles, whether it starts off with x squared or y squared is all depending on the shape of the graph. So a couple things we have to keep in mind. We're always going to set it equal to 1 before we graph. And remember, a squared is always underneath your leading term. So let me get to the point. Here we go. So our first equation, horizontal hyperbolas with a horizontal major axis, x squared over a squared minus y squared over b squared equals 1. Your vertices are a distance of a to the left and right of the origin. And you'll notice there are something called asymptotes that will help shape our graphs. These are basically lines that are the diagonals of an imaginary rectangle that we're going to use to graph. And don't panic when it comes to creating equations that you see of your asymptotes. Those are right here. We'll see that it's very easy to do. It's just about counting blocks, remembering what your a and b values are. On the right hand side, our vertical axis hyperbola is where y squared leaves it. Notice our what look like mini parabolas open up and down. We're going to jump right to the point of graphing now. And we're going to take a look at a couple examples. We're not doing all four. I'm going to try to keep these short and sweet. I'm going to choose one from the top two because those are identical. I'm going to do problem number 1. Example 1. Notice our x squared is first, so we're going to have a parabola that opens sideways. A hyperbola, excuse me. So we're going to find our a first. A squared is 9. A is equal to 3. And our b squared is 25, so b is equal to 5. Next, we're going to find our value of c. If you paid attention on the other side and looked at it, it looks exactly like Pythagorean theorem this time. Whereas with our previous, it was a squared minus b squared. So here we go. C squared is 9 plus 25. C squared equals 34. C is equal to the nice square root of 34, which is roughly 5.8. And moving forward, now what we're going to do, if you notice my numbers, we have a 3 and a 5. I'm going to go 5 in each direction. Oops. And what I'm going to do from there is I'm going to make that box I'm talking about. I'm going to go 3 to the right and 3 to the left. Those are the x direction. A was underneath x. I'm going to go 5 up and 5 down. That just created an imaginary rectangle. So I'm going to square it off, draw it as dotted lines. We've just started our first hyperbola. From there, we know we have asymptotes that start at the center and pass through the corners. So I'm just starting at the origin, which is where our center is, drawing each of our slant asymptotes that are going to help shape it. Now to get our graph going, I'm going to switch over to a red pen again. We got a vertex here and a vertex there because A is our distance underneath x squared, which means we're going to go along the x-axis. To sketch our graph, we're just going to kind of come up and stay within the confines of those two asymptotes. No other points needed. On the left side, same thing. Come down towards the asymptote. Don't go into the box and surround it. Next up, we do have to give our details. Our vertices are plus or minus 3, 0. Our foci are plus or minus root 34, 0, because those are at 5.8. 2, 3, 4, 5.8. There's foci and a foci. And last but not least, our asymptote, y equals plus or minus. Now to get the slope, you went up 5 over 3. Rise over run. Done deal. Next one up here, we're going to look at, we'll come back to it in our next video.